Good afternoon, students. Here we are again. Today, however, we will look at a motion problem, motion involving speed and distance and time. If you are, say, in an American school, you would be doing this kind of problem in Algebra 1. If you are in, say, Rwanda, you're likely to be doing this kind of question in a Senior 1. So we will look at this problem, and we'll try to see how to solve a problem of this type. Let's look at the problem. It says, a car leaves Kigali and travels towards Musanze at a speed of 45 kilometers per hour, or kilometers per hour. At the same time, and that's important, at the same time, another car leaves Musanze and travels towards Kigali at a speed of 50 kilometers per hour. If the distance between Kigali and Musanze is, let's say, 95 kilometers, actually the distance is probably maybe about 98 kilometers, but let's use 95. If the distance between Musanze is 95 kilometers, when will the cars meet? How far from Kigali will they meet? So we have a situation where there are two cars. One at Kigali, let's call it Kigali, and the other at Musanze. So the car from Kigali travels towards Musanze, and at a speed of 45 kilometers per hour. And the car from Musanze travels towards Kigali at a speed of 50 kilometers per hour. We assume that they travel the same road, and the distance between the two roads, distance between the two cars rather, or distance between Kigali and Musanze is, in our problem, it is 95 kilometers. And we want to know when and where will they meet. So let's go over what we're doing. From Kigali, a car is traveling towards Musanze. From Musanze, another car is traveling towards Kigali. And they're on the same road, and the distance between the two of them is 95 kilometers. We want to know, when will these cars meet? When will they meet, and where? Okay, we don't know when they'll meet. So we can use a variable. Let the cars meet T hours after the start of their journey. So we know we want them to meet T hours after. T could be 1, 2, 3, 4, 5, we don't know. But let them meet T hours after. That is, it could be 1 hour after the start, 2 hours after they started, 3, we don't know. But let it be T. This is a variable, some unknown quantity. Now, but what we know is this, that the distance traveled, okay, let us say that they meet at some point here. Let's assume a point here. Let's call this distance V1. So let's call this distance V2. We know that when they meet, if they meet at this point, D1 plus D2, D1 plus D2 must be 95 kilometers. Why that has to be? Because D1 plus D2 is the initial distance between the two cars. So D1 plus D2 must be 95. And that's important. D1 plus D2 is 95 kilometers. So that helps us a lot, because D1 is distance traveled. So the distance traveled by this car from Kigali That's D1, and the distance traveled um, by the car from Musanze would be D2. So when they meet, and this is the issue. When they meet, they would have traveled together the total distance. But what is D1? D1 is distance. This D1 would be equal to the rate, 45 kilometers per hour, 45 rate by the time it takes to meet. Because distance traveled is the rate or the speed multiplied by the time. So our D1 is 45t. Now our D2, the speed is 50 and the time is t. So D2 would be 50 by t, because we can say that distance is equal to the speed multiplied by the time. And that's what we did here. The distance traveled, D1, will be the speed multiplied by the time it takes, and D2 will be speed multiplied by the time it takes. But we said that D1 plus D2 is 95. So 45t plus 50t plus 50t would be equal to 95. So 45 plus 50, that happens to be 95t, would be equal to 95. So divide both sides by 95. So t would be 1. But that would be because our speed is miles per hour, so 1 hour. So in other words, when will they meet? They will meet 1 hour after the start of the journey. They will meet 1 hour after the start of the journey. Where will they meet? Where will they meet? We know that. Or how far from Kigali will they meet? Let's say they meet here. How far is that from Kigali? Well, we know that D1 is equal to D1 equals to speed, which is 45 by time, which is 1. So D1 is 45. So in other words, they meet 45 kilometers from Kigali. And if you want to check, D2 would be 50, and 45 plus 50 would be 95. So the time it takes for them to meet is 1 hour, and how far from Kigali will they meet? Well, D1 is 45. 45 by 1 is 4. They'll meet a distance of 45 kilometers from Kigali. Now, the important thing about this problem is simply this. We need to understand this idea. And this is that the distance traveled by the first car, distance traveled by the second car, that would be the total distance between the two cars initially. So D1 plus D2 would be 95, and that have the t, the time in hours, is 1 hour. So that's our problem. Thank you. Now you may, if you look at the video, you may like. If you care to, you may subscribe. I will have these videos every week, at least one video every week. And you can like them if you do like them, and subscribe if you want to. Now, this is Algebra 1 or Senior 1. I'll be doing videos in Senior 1, 2, 3, 4, 5, and 6. So that is, each person in every senior class will be able to see a video on topics that you would do in your senior classes. Thank you.